We're going to do a little bonus lab work here, actually, and another couple of labs that I've never put in a course that I think you'll enjoy. And we're going to put these on router 4, which is also our frame relay switch in our network. The only connection it has to our network is that it's on the same Ethernet segment as routers 2 and 3. We're going to join it to there shortly, but right now we don't have any IP addresses on this router. Because I know one of you, at least, probably all of you, were thinking, hey, because this is the way my students think. They're always inquisitive. It's like, okay, I got the RID rules down. That's no problem. I'm ready to go. But what if there weren't any IP addresses on the router? What if there weren't any loopbacks and there weren't any physical interfaces with IP addresses? What then, genius? What kind of RID are we going to have then? Well, let's find out. Let's go ahead and do a conf t here. You saw one really odd thing right away. Notice the config prompt stayed the config prompt. It didn't even go to config-router. And we got a big message immediately, and it's OSPF for no RID, no router RID. And there you go. OSPF process 1 cannot start. There must be at least one up interface for OSPF to use as the router ID. So that's the message that you get if you try to run OSPF without any IP addresses at all. So let's go ahead and join up. Let's do it right this time. Let's go to the Ethernet interface and we'll add it to that subnet. Let it cook there for a second. We'll send some pings over and then we're going to join area 23. Or will we? So the line protocol just went up. And let's go. If I lose the first one, then the rest will go through. Yep. And now if you send one to either one of those, they'll be 100%. And that's it. So we've got ping ability. Now let's see if we have OSPF ability. So we looked at some troubleshooting messages earlier with the adjacency. So we saw all kinds of messages, the debugs, we ran everything else. But what if there's an area mismatch? Because we know that potential neighbors have to agree on the area. Let's try to put router 4's Ethernet 0 interface into area 0, because we know it's area 23 between routers 2 and 3. And let's see what happens. Console by console. Don't see anything else yet. But I also don't see any adjacencies coming up real fast. And on an Ethernet segment, you'd think we'd be getting that pretty quickly. So let's run debug IP OSPF hello. And since this is an Ethernet segment, we should see some hello packets pretty quickly. We hope. It always takes longer when you're waiting. Let's run our adjacency too. So it looks like something is terribly amiss. Okay, so we're getting some kind of, it's kind of doing a self-election here. And now we're getting some debugs. You can see a DR-BDR election, but it's kind of electing itself and obviously not talking to anybody else because all we see in there is 23.4s. And we see with our debugs what the real problem is here. We're receiving the packets from .2 and .3, but you can see in here it says area 0000, which of course is area 0 to us. Mismatch area 23 in the header. So what it's saying, we're getting packets from .2 and .3 that we think from router 4's vantage point are in area 0 because that's the command we put in. And we're saying, hey, we're getting packets from potential neighbors, but the area is wrong. So this is what you'll see when there's an area mismatch. And we will go ahead and fix that. Excuse me, we'll do that with the router OSPF1 command. Up arrow to repeat. Control A to go in the front, take it off. Up arrow to repeat again. I'll just backspace there and put in 23. It's the only real keystroke shortcut I use, but I really like that one. And let's see what happens now. And all of a sudden we're getting some full adjacencies. We've got it to router 2. and router 3 is right behind it. But that's another great debug output for you to know. And obviously, again, it's screaming at you what the problem is. That's the great thing with OSPF debugs. You know, OSPF can get pretty complex, and you're seeing a little of that now, and you'll see more of it in the future. But the great thing is the debugs just are telling you exactly what you need to know. There's no, code or interpretation necessary. You're looking at mismatch area 23 in the header, so you know you've got an area of mismatch we've got to fix. Now let's say that we want to set router 4's RID, and we're going to try to set it to a RID that someone else is already using. And we know what these are going to be. But we see router 3 and router 2. Router 3 is the DR on the segment. Router 2 is the BDR on the segment. So what we're going to do is set it to 3333 here on router 4. Whoops, and we need to go into OSPF first. And we get the old clear IP OSPF process. And I'm going to say yes, because I'm that kind of guy. And let's see what we get this time. We get them torn down, and we get another router duplicate message almost immediately. But let's stick with this for a moment. Now we have our adjacency to router 2 already back up. That's already gone from loading to full, loading done, etc. So that didn't take long. We know we're going to lose our adjacencies. But look at the message we got for router 3 immediately. Duplicate router RID neighbor. OSPF detected duplicate router ID 3333 from 172.23.23.3. So what? So buttons. What does that matter to us? Well, the one thing I don't see here is a message about neighbor 3333 on Ethernet 0 going from loading to full. The adjacency to router 2 is unaffected. That's not a problem. So let's run show IP, OSPF neighbor. And you can see there, everything's fine with router 2. We have an adjacency and everything's lovely. But there's a real problem here. Because first off, router 4 is seeing router 2 as the DR of that segment, which to us, to router 4, it is, because that's the only neighbor adjacency it has. So the router ID is showing us here that if you have the same router ID on multiple routers in OSPF, you're going to run into adjacency issues. It doesn't mean you won't form any adjacencies at all, but you will not form any kind of adjacency with the other router that's already using that RID. So let's get rid of that, no pun intended. Pun intended? Happy accident. Router ID, we'll set it to 4444. We'll clear the process again. I obviously forgot to put logging synchronous on this one because it's interrupting my command. And there's 222 going down. Of course, 333 is not going down because it's already there. The adjacency to 2 is already up. And there's your adjacency to 3. So everything is beautiful. And let's go show IP OSPF neighbor. And you can see now that we are back where we were. Router 4 sees 3 as the DR correctly and 2 as the BDR. So really 3 great situations there where you got to do a little bit of troubleshooting. We saw that first off, we have to have an IP address on some interface on the router to even begin OSPF. Then we saw what the debug is going to look like when we have an area mismatch, and we also saw the message that we get when we have a duplicate router ID in an OSPF. Those have to be unique, or we're going to lose our adjacencies. Next coming up is that LSA discussion. I'll see you there.